turn to your next blank page in your journal, put today's date at the top, and put your title, Lesson 4-3, Ratio Tables. We have two new vocabulary words that we need to add to our journal today. The first one is ratio table, and you need to know that a ratio table is a table that shows equivalent ratios. And remember that the word equivalent just means equal. So it's going to show that two ratios are equal to each other. Our second vocabulary word today is variable. A variable is a letter that is used to take the place of an unknown number. Now, any letter of the alphabet can be used as a variable. The most common used variables are X, Y, A, B, and C. Now, those are not the only letters that can be used as a variable, but those are the most common. So today in our ratio tables, we are going to be using a variable to take the place of an unknown number that we are trying to find. Let's look at question number 1. It says a recipe calls for 5 cups of water for each cup of pinto beans. Use the ratio table to find how many cups of water should be used for 4 cups of pinto beans. We have 2 different strategies we're going to use today, and the first one is by finding a pattern. So please hit pause, draw your ratio table, and then press play again. Now that you have your ratio table drawn, let's fill it out together. I need to look in the problem for how many cups of beans and how many cups of water I'm starting out with. Notice it says I have 5 cups of water, so next to cups of water I'm going to put a 5. And it says for 5 cups of water, that will be enough for each cup of pinto beans. The word each means 1. So for every 1 cup of beans, I will need 5 cups of water. Now let's see what else we know in the problem. We know that we are going to use 4 cups of pinto beans. So I'm going to come down here to the end, and I'm going to put 4 cups of beans. And the question is asking me for how many cups of water. So I'm going to put a variable, and I'm going to choose to use the variable X. You can use any letter you want. And we're going to solve for X. We are going to find out how many cups of water it's going to take for 4 cups of beans. For this first example, we're going to find a pattern. So for example, if 1 cup of beans needs 5 cups of water, how many cups of water will 2 cups of beans need? You're right, we'll need 10. So if we have 3 cups of beans, that's going to be 15 cups of water. So if we have 4 cups of beans, we are going to need 20 cups of water. So X, or my variable, is equal to 20. Now, some of you are probably seeing another way to solve this problem, so let me show you another method. Here's method number 2. I want you to press pause, draw your ratio table, and when you're ready, hit play again. Okay, we're starting out with the same information. For 1 cup of beans, we need 5 cups of water, but I know that I need a total of 4 cups of beans, and so I'm looking for X, the cups of water. Think of this as our equivalent fractions, but we have it in a table. So I ask myself, what do I do to get from 1 to 4? Times 4. And remember, whatever I do to the numerator, I have to do to the denominator. So 5 times 4 is 20. So X is equal to 20 cups of water. Number 2. A recipe for punch calls for 3 cups of juice for every cup of soda. Remember, every cup means 1 cup. Use a ratio table to find how many cups of juice should be used for 5 cups of soda. So first we're going to draw a ratio table, and we need to label. We're comparing cups of juice and cups of soda. So juice and soda. We're going to start by writing our ratio of juice of soda. So it's 3 cups of juice to 1 cup of soda. So my ratio is 3 to 1. Now I know that I have 5 cups of soda. So my 5 cups of soda is going to go over here on the bottom across from soda. I need a variable up top. So I'm going to use the variable n this time. And I'm going to use equivalent ratios, which are like equivalent fractions. So to get from 1 to 5, I multiply by 5. I do the same on the top. So 3 times 5 is 15. So we are going to need 15 cups of juice to mix with the 5 cups of soda. So notice, we've been finding equivalent ratios and equivalent fractions for quite a while now. Remember, you must either multiply or divide to find your equivalent ratios. Number 3. Texas has over 900 species of spiders. Use the ratio table to find how many legs a spider has. So draw your ratio table, please. Now notice, we know that the ratio of spiders to legs is 4 to 32. But the question wants us to use the table to find how many legs a spider has. A spider means 1 spider. So I'm going to come a number of spiders and put a 1. And I'm going to use a variable, and I'm going to use the variable n. And then I'm going to solve my ratio table. So I have to ask myself, what do I do to get from 4 to 1? And I divide by 4. So I do the same on the bottom. So 32 divided by 4 is 8. So n is equal to 8 legs. So 1 spider has 8 legs. I want you to try number 4 on your own. Draw the ratio table in your journal. When you're ready to check, you may hit play again. Okay, let's check number 4. It says each apartment in Jerome's building has the same number of windows. Use the ratio table to find how many windows each apartment in the building has. Well, it gives us the ratio of apartments to windows is 8 to 32, but it doesn't want to know how many windows are in 8 apartments. It wants to know how many windows are in each apartment. So each apartment means how many? You're correct, 1. So number of apartments, it's going to be 1. I'm going to use a variable for number of windows. Now I'm going to solve for n by using equivalent ratios. So what do I do to get from 8 to 1? Correct. You should have divided by 8. So I have to divide by 8 with 32. So 32 divided by 8 is 4. So that means for every 1 apartment, there are 4 windows. If you got that right, give yourself a smiley face. Number 5. Coco used 12 yards of fabric to make 9 blouses. Use a ratio table to find the number of blouses she could make with 20 yards of fabric. So let's start by sketching our ratio table. We're comparing yards of fabric to blouses. What is our ratio of fabric to blouses? It is 12 to 9. But I don't want to know how many blouses with 12 yards of fabric. We want to know how many blouses with 20 yards of fabric. Since yards of fabric is on top, I need to put 20 yards of fabric on top. And I need to use a variable, so I'm going to use the variable X next to blouses. Now notice, I can't do anything to get from 12 to 20, so we're going to have to try something different. So here's what I noticed with 12 and 9. I noticed that I can simplify that. So I'm going to divide both of those by 3, and that's going to give me the ratio 4 to 3. Now notice I'm able to get from 4 to 20 by multiplying by 5. So I'll also need to multiply 3 times 5. So X is equal to 15 blouses. So that means if I have 20 yards of fabric, I make 15 blouses. So notice if I can't get from one number to the next in one step, I might have to do 2 steps. I may have to simplify first and then multiply. Number 6. Mrs. Wallace ordered 8 bottles of paint for 18 students. Use a ratio table to find the number of bottles of paint she would need to order for 27 students. So first we have to figure out what 2 things we're comparing. We're comparing bottles of paint to students. So bottles of paint to the students. What is our ratio of bottles of paints to students? It is 8 to 18. But I don't want to know how many bottles for 18 students. I want to know how many for 27 students. So students is on bottom. So I'm going to put 27 on bottom. And add a variable. This one I'm going to use the variable P for paint. And now we're going to solve to figure out what P is equal to. Now notice, I can't do anything to get from 18 to 27, so I'm going to see if I can simplify my ratio. And both of those are even, so I know I can simplify by 2. So the ratio 8 to 18 simplifies to 4 to 9. Now I notice I'm able to do what to get from 9 to 27? That's right, multiply by 3. So I'll also have to multiply the top row by 3. So 4 times 3 is 12. So I'm going to need 12 bottles of paint for the 27 students. Number 7. It takes a worker 70 minutes to pack 120 cartons of books. The worker has 14 minutes of work left. Use a ratio table to find how many cartons of books the worker can pack in 14 minutes. So let's start by making our ratio table. And let's figure out what we're comparing. We're comparing minutes to cartons. So let's put minutes over cartons. What is our ratio of minutes to cartons? It is 70 to 120. I know how many they can package in 70 minutes. I want to know how many cartons they can package in 14 minutes. So where do I need to put my 14 minutes? You're correct, on top with the minutes. So I'm looking for the number of cartons, so I'm going to choose a variable, and I'll choose the variable C. Can you think of anything I can do to get from 70 to 14? If not, let's see if we can simplify. Well, I notice that both of my numbers here end in 0, so I know I can simplify by 10, and that gives me 7 to 12. Now, to get from 7 to 14, I can multiply by 2, so I'm going to multiply 12 times 2 to get 24. So if she has 14 minutes of work left, she can package 24 cartons. I want you to hit pause, try number 8 on your own, and then we'll check it. Okay, let's check your work. It says Maya wrote 18 thank you cards in 15 minutes. She has to work on her thank you cards before tennis practice. Use a ratio table to find how many cards she can write in 10 minutes. So you had to know that we were comparing thank you cards to minutes. So I'm comparing cards to minutes. The ratio of cards to minutes was 18 to 15. But I didn't want to know how many cards she could write in 15 minutes. I wanted to know how many she could write in 10 minutes. So I'm going to put my 10 on the bottom with minutes. I'm going to choose a variable to use for cards, and I chose C. I noticed that I couldn't do anything to get from 15 to 10, but I noticed I could simplify the ratio 8 to 15 by 3. So the ratio 18 to 15 simplifies to 6 to 5. Now I notice I can get from 5 to 10 by multiplying by 2. So I'm going to do the same on the top. So 6 times 2 is 12. So I now know that Maya can write 12 cards in 10 minutes. Turn to your next blank page in your journal. Divide your paper into 8 equal boxes. On questions 1, 2, and 3, I want you to draw and complete each ratio table. Then questions 4 through 7, you have to create your own ratio table and then